Welcome, explorers, to the Coded Universe, your gateway to the mysteries of programming. As we traverse this cosmic expanse, we'll uncover the secrets of object-oriented programming, often known as OOP. Much like the celestial bodies that form our universe, OOP is composed of objects, each with its own unique traits. Our mission today is to decode this enigma, to understand how these objects interact, form relationships, and create the vast coding realm we know. So buckle up. Let's embark on this journey without a single line of code. Envision this toy factory. Instead of crafting each toy uniquely, it produces parts. Heads, bodies, arms, and legs, all made independently yet with a shared purpose. Picture a conveyor belt constantly churning out these toy parts, each identical to the last, each ready to be part of something more. Now imagine a team of skilled toy makers at the end of the line, assembling these parts into various toys. A teddy bear here, a robot there, perhaps even a superhero or two. From the same parts, a multitude of toys are born, each different, yet all made possible by the same reusable components. This mirrors object-oriented programming. In our vast coding realm, objects resemble these toy parts, ready for reuse and assembly in countless ways. They form the building blocks of our programs, allowing us to create complex systems from simple, reusable elements. Much like these building blocks, each object in OOP has its traits. Objects in object-oriented programming are not just inert blocks. They are dynamic entities with their own unique characteristics and capabilities. Consider them as the building blocks of your program, each with its own color, size, or shape. These blocks or objects aren't just standalone entities. They interact with one another, share information, and even transform based on these interactions. They can be moved around, rearranged, and manipulated to create different structures. In the same vein, in the realm of OOP, objects aren't merely chunks of data. They come bundled with their own set of operations or methods. This combination of data and methods makes objects powerful and flexible tools. And just as you can construct a tower, a bridge, or a castle from the same set of blocks, you can build diverse programs using the same set of objects. And akin to assembling these blocks, we can organize and manipulate these objects in our virtual canvas. Now, why does OOP matter? Imagine making sense of this chaotic mound of papers. Seems daunting, doesn't it? It's like trying to find a needle in a haystack. You know it's there, but it's lost in the disorder. Now imagine if these papers were neatly arranged into folders, each labeled and organized. Suddenly the needle isn't so hard to find. It's in its designated place, waiting to be picked up. This is the magic of object-oriented programming. It categorizes and structures the code, turning a chaotic mess into an ordered system. It's like having a personal librarian who knows exactly where every book belongs. In the world of code, OOP is our librarian. It ensures everything is in its place, making it easier to find, modify, and manage. So the next time you're faced with a daunting pile of code, remember, OOP is our savior here. It categorizes, structures, and brings clarity, turning chaos into order. Wondering about OOP's magic? Behold this city. Picture each building as an object within our programming universe. Each structure, with its distinct architecture and purpose, mirrors an object's unique properties and methods. Now let's delve deeper. Imagine a skyscraper, each floor representing different operations. Does a renovation on the 30th floor affect the lobby? Not at all. Similarly, in OOP, revising one object doesn't disrupt another. Consider a city hospital. It has different departments, each handling specific health concerns. Picture each department as an object, performing unique functions yet remaining part of the bigger entity, the hospital. This is the essence of encapsulation in OOP, where data and methods are bundled together. But what about the city's infrastructure? The roads, the bridges, the subway. They interconnect the city, allowing smooth operation. In our OOP city, these represent the relationships between objects. Just as a bridge connects islands, OOP interlinks different parts of a program, ensuring a seamless dance of code. So there you have it. OOP is like a well-oiled city. It's a way of organizing code, of making it more understandable, more flexible, more manageable. It's a way to turn chaos into order, to build grand cities out of simple building blocks. And as bridges bind islands, OOP interlinks program parts, ensuring a seamless dance of code. Let's embark on our last leg of this cosmic voyage into object-oriented programming. We've seen how OOP shapes the city, but how does it shape the coder? Like an architect, you design and develop objects, structuring them to your needs. You become the master of your code universe, controlling how objects interact and function. It's like being the mayor of your own city, deciding where to build roads, erect buildings, and establish connections. This power comes with responsibility, but also with immense creative freedom. With OOP, you can build cities, planets, or whole galaxies. It's all up to your imagination. And as we journey deeper into the universe of OOP, we'll encounter even more exciting concepts. Polymorphism, inheritance, abstraction, these are the stars and galaxies waiting for us to explore. So buckle up, coders. This journey into OOP is just the beginning. The universe of code is vast, and there's so much more to discover. Thanks for joining us on this cosmic voyage into object-oriented programming. Don't forget to subscribe to Coded Universe for more such interesting videos. Until next time, keep coding, keep exploring,